then remaining will be N minus X. And what is the concentration of B? That is X. And concentration of C, what is that? That is also X. Then at equilibrium we can write the equilibrium constant. K is equal to, now what is that? Concentration of B into concentration of C divided by concentration of A. So substitute the value of their concentration. Here concentration of B is X, concentration of C is also X, divided by N minus X. So K is equal to S square divided by N minus X. So by solving this equation we will get the value of X. So we can calculate the equilibrium concentration. So these are the three applications of equilibrium constant. Next we will go to the very important topic, that is factors affecting equilibrium. Factors affecting equilibrium. That we will discuss with the help of a principle that is a very important principle, that is called Le-Chatlier principle. So what are the factors which affect the equilibrium? Before going to discuss about the effect of change of factors like pressure, volume, temperature, etc., we'll state this law. We already learned this law in lower classes. So Le-Chatlier principle states that at equilibrium, for a system which is at equilibrium, it is resting at equilibrium. Here a particular forward reaction is proceeds in particular rate and backward reaction proceeds in same rate, and they reaches an equilibrium. They have constant value of pressure, volume, temperature, concentration, etc. That is a stage of equilibrium. At this stage, if we try to change, when we using by external force, we try to change pressure or volume or temperature or concentration, any of these properties which will disturb the equilibrium will try to undo that change or nullify that change. That is called Le-Chatlier principle. So I will state the law. If we try to change any macroscopic property or any measurable properties like pressure, volume, temperature, concentration for a reaction at its equilibrium stage, the system will try to, or that reaction mixer will try to undo that change or nullify that change. That is called Le-Chatlier principle. Once again I will say, if it's try to change any measurable properties like pressure, volume, temperature, concentration, etc. for a system at equilibrium, it will try to undo that change or it will try to nullify that change. That is called Le-Chatlier principle. It has so many applications in production side that we will discuss later. So that is Le-Chatlier principle. So according to that principle, if we try to change any properties, pressure, volume, temperature, concentration, any property, the system will try to nullify that change. If we increase pressure, they will decrease pressure. If we increase temperature, they will try to decrease, or they will reach us in equilibrium always. If we disturb that equilibrium, they will easily reach us in that equilibrium. So first we will consider effect of change of concentration. Effect of change of concentration, either the reactants or products. For that we have to consider an example. We'll take an example. Nitrogen gas combines with hydrogen gas and NH3 gas. It is called Haber process. Takes place in presence of a catalyst called spongy ion. Here reactants, all the reactants are in gaseous state. So in this case, if we add or if we increase the concentration of these reactants by pumping so many nitrogen gas inside the equilibrium. It is equilibrium happens in a closed system. So using an external agent, if we are adding or we are increasing the concentration of reactants, what happens? The equilibrium disturbs, it will lost equilibrium stage because it is in a balanced stage of reactants and products. If you increase the concentration of either of these reactants, the concentration of reactants increase. Then system want to change or nullify that change. What will it do? Okay, it has to decrease the concentration of reactant. So only way to proceed in forward reaction. So the equilibrium will shift towards right, like a balance. It is like a balance. So if we increase the concentration of product to make it balance, then some of the reactants are converted into products. Then it will reach us in the again in the equilibrium. So we can say that equilibrium shifted towards right. Or what type of reaction takes place? Forward reaction takes place. So if we want more ammonia, we have to always increase the concentration of reactants. Then second one, so if we increase the concentration of reactant, what happens? Equilibrium will shift towards right, or what type of reaction takes place? Forward reaction. Then second condition, if we increase the concentration of product, what will happen? If we increase the concentration of product by using a pump, we pump some NH3 gas into the system. Then system want to decrease that concentration of ammonia. What happens? The equilibrium will shift towards left. Or what type of reaction takes place? Backward reaction takes place. So if we increase the concentration of reactants, forward reaction, equilibrium will shift towards right. If we increase the concentration of reactants, backward reaction will take place, that is equilibrium will shift towards left. Then third condition, if we decrease the concentration of reactants, we are taking some amount of nitrogen gas and hydrogen gas from the equilibrium mixer. What happens? Concentration of reactants suddenly decreases. It will lose the equilibrium. Then system will try to nullify that change by what happens? By shifting left. That is what type of reaction takes place? Backward reaction. So if we decrease the concentration of reactants, what type of reaction takes place? Backward reaction. Fourth one, if we decrease the concentration of product, we are pumping out ammonia. We want more ammonia, so we are pumping out ammonia, produced ammonia from the system. What happened? Concentration of product decreases. The system want to increase the concentration of product, so the equilibrium will shift towards right. That means what type of reaction is called the forward reaction takes place. So these two conditions are the favorable condition for increasing the production of ammonia. What are that? That is, either we increase the concentration of reactants or we decrease the concentration of product. In both that case, reaction will proceed in forward reaction. That is, large amount of ammonia will be produced. Otherwise, it will reach an equilibrium that only fixed amount of ammonia is produced. So if we want more ammonia, we have to increase the concentration of reactants or decrease the concentration of product. Then the other two conditions are not favorable for the production of ammonia, that is by decreasing the concentration of reactants or by increasing the concentration of product. What type of reaction takes place? Backward reaction will take place. There is no benefit from that reaction for the production of ammonia. So in generally we can say that if we increase the concentration of reactants or decrease the concentration of product, reaction will always proceed in forward reaction. Or if we decrease the concentration of reactants and increase the concentration of product, the reaction will take place in backward reaction. That is the effect of change of concentration of reaction mixture. That is the first factor. Okay, we'll go to the second one. Effect of change of pressure. So we know that the effect of change of pressure will be affected only those reactants which are in gaseous state. It has no effect of reactants which is present in solid or liquid state. So for a reaction it contains only solid reactants and product, or for a reaction which contains only liquid and solid, only liquids. For that reaction, if we increase pressure or if we decrease pressure, there is no change, or it will not affect the equilibrium. So it will, pressure has an effect only for those reaction which contains gaseous reactants and product, or gaseous molecules in product side or in reactant side. Both sides, if there are gaseous reactants, pressure has changed. Then we can consider an example, the same example we can consider because it is in gaseous state. Nitrogen gas combines with hydrogen gas, produce ammonia gas. Here pressure has an effect because in reactant side there are gaseous reactants, and in product side too there is a gas product. Here 1 plus 3, how many moles of gaseous reactants? We have to consider that also. There are 4 moles. Here there is only 2 moles. So there must be difference in number of moles too, otherwise it has no effect. So in reactant sides 4 moles of gaseous reactants, and in product side 2 moles of products. In this case there is an effect of pressure in equilibrium. So we can discuss how it affects the equilibrium. First condition, if we increase pressure, there are so many methods for increasing pressure that we will discuss later. So if we increase the pressure of by pumping any of this gas, we can increase. So if we increase the pressure of the system, we know that at equilibrium there is a constant value of pressure. Suddenly if you are increasing the pressure, system want to try to decrease the pressure, to try to nullify that change. How can we decrease the pressure of the system? We cannot take some gases from outside. System cannot do that alone. So here there are 4 moles and there are 2 moles. We already learned that pressure depends on the number of moles of gaseous reactants, gaseous molecules. So reactant side there are 4 moles and products there is only 2 moles. So if we increase pressure, system want to decrease the pressure. That is, system want to decrease the number of gaseous molecule. So in which direction the number of molecule is less? If it is in some cases in reactant side or some cases in product side. Here product side only 2 and reactant side there are 4. So to decrease the pressure, the equilibrium will shift towards right. That is, here forward reaction takes place. In this case, there is forward reaction. We cannot generalize for all that reaction. That we have to find out by counting the number of molecules before and after the reaction. So in this case, if we increase the pressure, system can be decrease the pressure by proceeding to a direction which containing lower number of gaseous molecules. That is, here it is in right, that is, it will proceed to forward direction. Clear? Second condition, if we decrease pressure, if we decrease pressure, system want to increase the pressure. It has to reach an equilibrium. So what happened? To increase pressure, more number of molecules is needed. So some of the ammonia will readily decompose and produce nitrogen and hydrogen. They will shift towards left, that is backward reaction takes place. So in this case, if we increase pressure, forward reaction takes place. If we decrease pressure, backward reaction takes place. So in generally we can say that if we increase pressure, the reaction will proceed in a direction which contains low number of molecules. And if we decrease pressure, reaction will proceed in a direction which contain more number of molecules. So in generally we can say like that. So that is the effect of change of pressure. First we have to think one condition. If there are only solid and liquid reactants and products, pressure has no effect. It has effect only in case of gaseous reactants and products, and their number of moles must be different before and after that reaction. Okay. Then we'll discuss the third factor. That is effect of change of temperature. We know that temperature also have effect only for some type of reaction. So reactions can be classified into three types based on the temperature. That is, some reaction there is no change in temperature. That is energy change, temperature change for that reaction is, some reaction will be zero. Some reactions will provides or will release us energy, temperature. That type of reactions are called exothermic reaction. So delta change, energy change will be